Okay. Now, you already have a copy of the presentation, so you can take notes if you want, that there is some space left for that in the handout that I distributed. Okay. Now, the key idea in this whole issue of information is, what is the value of using any type of information technology if it is going to make our system more efficient? This is the underlying idea. And so what we need to show is, we need to show that actually information helps us in reducing some of the variability and reducing our costs. So we need to show that. So in 1990s, when this issue came out, almost all the researchers wanted to show that information unavailability has as a disadvantage on the operation of the system, because without knowing the information, what you do is you increase your variability, hence your costs are increased. It turns out that the issue of most of the issues that we're going to talk about was probably discovered in 1970s and was written in different literatures like economics literature and so on. But this was a new perspective to put, which is basically the effect of the information on specifically operational issues. Now, potential availability of more and more information throughout the supply chain, implications of this availability on effective design and integrated supply chain. In other words, there are a number of issues. One of them is the value, and the second one is the technological availability. The third one is, now we have this, what are we going to do? So you can redesign certain systems in a much better way. So these are the things that will be discussed. And I will probably spend more time on the first one. The second one, I'll just give some examples. The third one, we're going to see over the course of the, within the course, we're going to see more things about that. Now, what are the information what is the information that are we talking about? Now, the information in the first glance is related to inventory levels. In other words, let's say that I am a big manufacturer. I'm manufacturing some fast-moving items like biscuits. Okay? I never see the actual data. Why? Because the actual data is at certain small markets and point of sales. We usually call it point of sales data. And that data is not available to me as a manufacturer unless I make a specific attempt or I spend some energy to get that data. That data is not going to be available to me. Now, the question here is that data going to be useful for the manufacturer? The point of sales data. So inventory levels in various different stages of supply chain, orders in various different levels of supply chain. Am I interested in the order that a small bakkal gives to a local warehouse? Well, it turns out that yes, because this is all pertinent information that you might need to cover. Similarly, I'm a retailer. I don't know anything about what is going on in the manufacturer side. So the information that I receive from the manufacturer with respect to production times, production deliveries, and delivery status, is it going to affect my decision? For example, let's say that you are bringing something with truck. Is the status of the truck important for you when you are making a new decision? In other words, the truck should be in Bulgaria, but it is in Yugoslavia. Is it going to affect your decision? So this is what we're talking about. Now, of course, I am going to increase this list. You can increase this list by saying that what is the cost, what are the costs that the manufacturer are incurring? The manufacturers are incurring. There might be more than one manufacturer. What is the cost of the retailer? How is the retailer giving the price for the item? What is the effect of price with the demand? Okay, you can increase this information, of course, but at this point, We are not going to be concerned with the cost, but this is the basic inventory and basic data related to units going from one place to the other or units being manufactured. Okay, so this is basically what we're talking about when we say information in this chapter, but when we start discussing contracts, we're going to see that information is not going to be only this, but we're going to have more information coming in. Okay. Now, of course, one thing which is hidden here is what are the, for example, you might need certain information when you give an order. For example, if you're talking about a supply chain where you have manufacture to order kind of products. In other words, you specialize a certain product and order that special product. In that case, of course, the information regarding to the product specification is also included in this. Because it turns out that traditionally, to convey that information is not that easy. Let's say that you are assembling a certain automobile and you are ordering a certain component to be manufactured in one of the companies, one of your suppliers. So what you need to specify is you need to specify the product in such a way that when you receive that product, it is going to be immediately usable in your assembly. Okay? So it turns out that, of course, once you start doing it, it is easy. But in the first place that you are ordering, it's not that straightforward. And we're not going to see those kind of things here, but we're going to mention probably towards the end of the semester. I'm making a lot of promises for the end of the semester. I don't know when the semester is going to end, but there are a different number of issues that you can relate to these. That's the idea. Now, in general, we're going to show that more information will help reducing variability in the supply chain. Okay, so this is basically what we are going to end up with. After we see the analytical models, we will be convinced actually. Help suppliers make better forecasts, accounting for promotions and market changes, so on and so forth. So these are all the benefits, as you can see. And for example, enables lead time reductions. If I have information, then I can find where the problem is and I can reduce my lead time, so on and so forth. So all these things are enabled if you have correct information. Now, the main analysis is, with respect to the value of information, comes from observing the effect which is called the bullwhip effect. Now, bullwhip effect actually is simply can be described in the following way. Now, you have a certain customer demand. The customer demand does not have that much variation. Whereas if you go in the upper echelons of the supply chain, you started to observe the fact that inventory and backorder levels fluctuates there considerably across the supply chain. In other words, the customer has certain variability, but as you go up into the supply chain, up into the echelons of the supply chain, you see that that variability actually is more and more. So this is basically, the effect is called bullwhip effect, and creating the analogy between this inventory level increase and the shape of the bullwhip. When you basically, well, whip is actually the correct term, but bullwhip is the one which has very good material so that when you splash it, okay, it is going to give this kind of a sign, which means that the variability is low here. So when you go up, the variability is going to increase. That's the effect of whip when you splash it. Okay. So next is, okay, so we have a simple supply chain. This is an example which is given in, so what we have here is actually we have a 4-level supply chain. This is a picture from the paper by Lee. Okay, so what you have is you have a simple 4-level supply chain, and at the top you have the retailer, which is basically serving the customer, and then you have the wholesaler, distributor, and the factory. Now, note that in between these levels, you have, of course, order lead times and delivery lead times. Now, what do we mean by order lead time? Now, in practice, actually, when you give the order is not necessarily received on the other side instantaneously. Okay? So order lead time is basically, for example, if the wholesaler checks the orders only in the beginning of the week. Okay? So whenever you give the order, doesn't matter, it is going to be accumulated, and they are going to see it in the beginning of the week. Similarly, when a retailer is giving order, probably they are not going to give order at arbitrary times. They are going to accumulate the orders and start giving it at some point in time. And similarly, of course, you might require to write a lot of specifications, so that might be a need for some kind of an order lead time. So you might need to write a long list of specifications. So this is more or less what the supply chain is. Do you have any questions on that? Okay, this should be the figure 5.6 in Lee's paper, which is published in, I think, in Harvard Business Review. Let me see, not Management Science, but the other one. Yes. No, Sloan Management Review. Okay, the next page actually shows the order variability. This is the effect that I'm talking about. Now, to understand basically, this is what's happening, and let me draw what's happening here. Let's say that these are the inventory levels at the retailer, and this is the second level is the wholesaler. The third level is distributor, and then we have the factory. So this is actually a real data that they observe. So what's happening is that in every axis we have time, and on the other axis we have order quantities. Now, actually, the customer demand is at the top. It shows little variability. But when it comes to the retailer orders in this pattern. What is the meaning of this? There is a certain pattern that retailer orders. We are not expecting the retailer to order after every customer. So there is some kind of an accumulation. So you give an order here. So this is some of the orders which is coming from all the retailers. So what's happening is that you see that on Mondays you have a lot of orders, and then the orders decrease and then increases. Now when you look at the wholesalers ordering the distributor, you are going to see this even more variable. And finally, when the distributors are ordering to the factory, this is going to be even worse. So this is basically the idea of bullwhip effect, and this is what you see in the cumulative way in the figure. Okay, so this is the bullwhip effect, and we can observe this. This is a reality. Now, how are we going to explain this? So this is the key issue. Any questions on this? Sorry about this figure mess up, but I said that I was not going to talk about the technology, so I'm not very much aware of what's going on. Okay. Now, what are the factors that contribute to this variability? Now, we are going to count a number of factors. So each of them has a contribution to this variability. Now, one of them is the idea of demand forecasting. Now, first of all, you can see that retailer is observing the demand from the customers and then giving orders accordingly, has some expectations for the future, forecast the demand. Now, wholesaler only observes the orders that come from the retailers, which is the demand for the wholesaler. So looks at this pattern and says that this is the demand. So there is a high variability in the demand pattern that observes, but forecasts accordingly. So you can see that they are forecasting actually the same thing. They all want to forecast the customer demand, but this guy, retailer, is the closest doing it. But you have many retailers, they have their own ways of doing it. Okay, so there is no one consistent way of doing it. So as you go down, as you go up in the supply chain, everybody has their own way of forecasting. It turns out that this is creating a huge problem, and this is part of the variability, because they are not using the same thing. Now, so this is actually a certain case, which is in one of the recommended readings. It is by, I think I don't remember the first author, but I think the first author is probably Jennifer Ryan, and there are 3 or 4 authors. This is the paper published in, if I'm not mistaken, in Naval Research Logistics. You have in the list. So what they do is, you see each of them, let's just assume that each of them is going to have a periodic review policy, which means that they are going to review the system in certain intervals. So what does it mean? It means that their policy is going to be an order up to type policy. So for example, the retailer is going to look at the inventory on Mondays, and then every Monday they are going to order up to a certain level. Of course, this level is not necessarily stationary. They are going to forecast the demand, and for example, if they are entering a holiday week, the forecast is going to be accordingly. So, but the idea is that there will be a base stock level, which is the average demand during lead time and review period, plus you have a multiple of standard deviation of demand during lead time and review period, which is for safety stock. So this is the base stock level. Of course, this average demand is going to be forecasted every period. Okay? And the standard deviation. Now, estimation of the average demand and demand variability done is going to be using some standard forecasting techniques like exponential smoothing or moving averages or whatever. And so as you have more data, you modify the estimates. In other words, in the beginning of every week, you are going to update. This is the way that it is going to operate. And then safety stock and base stock level is going to depend on these forecasts. So order quantities are going to change, and the variability is going to increase because you will be using all these forecasts, and the next person is going to use your order and then do another forecasting at the top of that. Okay? So you can see that if you remember the forecasting topic, there is a certain error in every time that you make a forecast. This guy makes a forecast, and then at the top of it, this guy makes another forecast, and here you have another forecast which is done. So the errors actually accumulate. So this is the reason, one reason of why we have increasing variability. Very simple. Yes? Okay, now are you going to reduce the demand? This is the key issue. You cannot reduce the demand, but you are saying that why don't I, knowing this, decrease the standard deviation of the demand that I am observing artificially? This is what you are asking. Am I right?
Actually, the real demand is lower than what retailer gives to wholesalers.
No, okay, the demand is not lower. What is lower is the variability of demand. Okay? The actual demand is transmitted because the way that you are ordering is what? Like, let's say that you have everything stationary. So what happens is that you have the same base stock level every period. Okay, let's assume that. So what's happening? You are only going to order the quantity which is demanded in the previous period. So this is the routine that goes on actually. Because basically this is the ideal level. So in the previous period there will be some demand. So you're going to order that quantity only. So the demand, the units that you order is reflecting the demand. But the problem is the variability of demand is increasing. In other words, here I see that demand, expected value of demand is still the same, but the variability is pretty high because what is added at the top is the forecast error plus this forecast error plus another forecast error. So this is the basic idea. But the expected value is the same. So you cannot deflate the expectation because that's what is actually being demanded in the previous period. What is the main problem is actually the variability issue.
Maybe we can change the forecasting.
Okay, of course. Now the question is we can change the forecasting method. Of course. Now ideally you can use a very good forecasting method where everybody is going to use the same forecasting method. Okay, but the thing is, the retailers are independent entities, wholesalers are independent, and how are you going to make sure that all of them uses the same forecasting technique and same data? Now, we're going to see, of course, we're going to see how we can eliminate part of these effects, and we're going to see it towards the end of the hour. But you're right, actually. If we can bring all of them together and make one forecast rather than everybody doing different forecasting, you're going to reduce it. Yes?
If real customer demand information is available for operation,
Of course. Then it will be different.
then how are they going to modify their policies?
Okay. Question is, if the real information is available, how are they going to change, for example, wholesaler, distributor, their policies? Well, you can do certain things, but it's not clear. But of course, that will help you. But it depends on how you are going to utilize it. There are certain ways of doing it, like vendor-managed inventory. Okay? And if you utilize vendor-managed inventory, it means that you will be able to use that. What is vendor-managed inventory? It's very simply as follows. You don't let the retailer order, but you simply plan for the retailer. Of course, in order for this to be possible, you have to persuade the retailer, okay, which is not always the case. In other words, you might need more information. So there are different ways of utilizing that information depending on the agreement. So now what we are doing is we are observing the fact that there is this variability and we are trying to figure out what are the reasons. Then at the end, I'm going to talk about the remedies, how to eliminate that, actually. Okay. Now, the second one is the lead time. Of course, you can see why the lead time is going to be important. Now, if you have longer lead times, the demand variability is also going to change because remember we have the variability over the lead time and the review period, so on and so forth. So you can see that as the lead time increases, okay, you have the variability increasing. Because everything is added at the top. You have 2 days here, 5 days here, 7 days here, but eventually, when I see this, even if I am looking at 7 days of demand, okay, here, from here to here, actually, the original variability already contains the effect of the lead times in the previous cases. So you can see that everything is related. So, of course, now, again, you can ask the following. How am I going to use the fact that if I decrease the lead times? If the lead times are decreased, of course, we know how to use that. The safety stock levels will decrease, so I'm going to keep less safety stock, less costly operation. But this is also something that increases the bullwhip effect. Then we have the batch ordering problem. I already gave you that hint when I was describing. Okay? When you are ordering in batches, unfortunately what you do is you accumulate certain demand. It means that you wait for the demand to come to a certain level and then give an order. Okay? Now this is also changing the way that your upper echelon is seeing the demand. Why? Because if you basically order every time that a customer comes, Okay? The wholesaler is going to see those single orders one at a time, and they will also be able to follow the real demand pattern. Whereas what you do is you accumulate, you order on Mondays, the other guy orders on Wednesdays, the other guy orders once every other Tuesday, and so at the wholesaler, when you look at the demand that you are seeing, you are not observing the real demand, but basically accumulated demand. So this is going to have an effect, and we're going to see a mathematical model actually on how this is going to be true. Okay? Now, of course, on the other hand, we know that why do we have batches? Economies of scale. Remember, we have transportation discount. We have periodic sales quotas. Every firm, if you have worked with a firm, you know that they have some dates which are usually end of months. And what they are going to do is they are going to give promotions according to the total sales that is made in that month. So if you are a marketing person, you want to get the promotion, what you do is you work harder towards the end of the month. Okay? Now, this is definitely going to influence the way that you actually perceive the demand, which is very bad actually in terms of the operation. So there are many things that can be done, and we're going to talk about that actually. Okay, so this is what I'm sort of trying to tell the managers for years in systems design courses. You have to make those dates different for different groups of people working. So that one of the group is going to shoot for the 15th, the other one is going to shoot for the 20th. Now this is going to balance certain things within the month. And this is going to decrease, of course, the effect of these batch sizes. Okay, so we're going to see again those remedies. So this is another one. Another one is price fluctuations, of course. This is a dreadful case when you have inflation. Because when you have inflation, you have another motive of keeping inventories. So the general motive of keeping inventory is to create some kind of a cushion against uncertainty. But when you have an inflation, an environment with inflation, then it means that you have another motive of keeping inventory, which is the speculative motive. Okay? You know that the prices are going to increase in the future, so why not invest in inventory as if I'm investing in a bank? Okay? So those kind of things results in forward buying. Okay? When you go to the supermarket and you are deceived when you see toilet papers in group of 24 being sold almost 1 lira more than 12 toilet papers. Okay? So you have 12 of them being sold to 15 liras, and then 24 of them being sold to maybe 17 or 18 Turkish liras. So what you do is you forward buy. Actually, you are not going to use it in the next round, because we're talking about a huge quantity. So what you do is you forward buy. Now, similarly, retailers, wholesalers, distributors, all the guys are going to do the same thing. So the price fluctuations in that respect affect in this variability. Okay, so next thing. So what will happen is that you're going to order large quantities when there is discount, and then order like small quantities when there is no discount. So things are going to be messed up. Now, another one is, this is also typical. You inflate your orders for one reason. Maybe this is coming to the first question that we have. Now, when do I, as a retailer, will inflate my order? What do I mean by inflating the order? Well, I know that like regularly I have to order 20 units because that's bringing me up to the order up to level. But for one reason, I order 35 units rather than 20. Why? Because you usually have an expectation that there will be a shortage of this item. Okay? This is dreadful, actually. This is the worst thing that can happen for the supply chain. So what happens is that when the retailers start to give signals as if demand is increasing, okay, this is going to go all the way to the factory, this signal. Now, and what the factory is going to do is simply, I mean, what are you going to do if you see a lot of demand coming in? You're going to expand your factory. Okay, this is what happened in 1990s in the chip sector. Okay, there was some kind of a shortage in the market for a specific reason. I think maybe one of the factories stopped. So retailers started to give inflated orders. Okay, without knowing. I mean, this is the natural thing to do, actually. So when you give inflated orders, wholesalers took that as a signal of increasing demand, and eventually there was a lot of investment being done to manufacturing chips. And then it turned out that there was no real demand for that. So the whole investment was actually blown away, and that's the reason why still, I think, in different parts of the world, you have still factories, very large factories, which is manufacturing chips, and the demand, well, nowadays, of course, it's not a problem because demand is increasing, but in 1990s, they had a huge problem related to that. It's one of the failures of this whole mechanism. It's given as an example. I think you can find it in the internet, actually, even. So the problem is if you have periods of shortages, this is what you do, and this is going to affect the inflated orders. Now, for each of these, there are mathematical models which actually shows that this is going to be which shows the effect of the increasing variability under these circumstances. For example, this one is actually a game theoretic model that we are not going to see, but it is available in the management science paper of Lee, which we are required to read. But we are not going to see that model in detail. But basically, it is a very simple model, and it shows that the tendency, if you have shortage, then you will order a little bit more. Of course, we have to know what happens when, for example, what will happen if the wholesaler is short? How is it going to supply the retailers? There might be some favorite retailers which might be supplied in every circumstance, but some retailers are not going to receive anything. So in order to make their presence more significant, what they will do is they will start ordering more. Okay? So that they will become the favorite, and then they are going to manage the orders, the future orders accordingly. This is what they do, actually. So inflated orders in that respect is going to include the variability, increase the variability. Okay. Now, how are we going to quantify this bullwhip effect? Now, there are a number of things that can be done. And so what I will do is I will start with a few examples given in the text, and then probably we will end everything for the hour, and then I will give 2 mathematical models in the rest of the week. Okay. Now, for quantifying the bullwhip effect, let us consider a 2-stage supply chain where we have a retailer who observes the customer demand, and then retailer places an order to a manufacturer. So consider a very simple structure. And retailer faces a fixed lead time. So order placed at the end of period T, and order is going to be received at the start of period T plus L. So we have a lead time. And retailer follows a simple periodic review policy. So retailer reviews inventory every period, places an order to bring its inventory level up to a target level, and the review period is 1. You can see that if the review period is more, that will be even worse, because your demand during lead time plus review period is the key quantity. Okay, so given this system, Now we have this simple base stock level in terms of echelon stocks, of course, you can see, but we are only going to do this for the retailer. The base stock level is going to be what? We have this L times the average demand times Z plus standard deviation square root of L. So let us assume that L includes the review period. I know that the base stock level is, if it is continuous review, okay, the base stock level is going to be L. If it is periodic review, the base stock level should be L plus 1, actually, if you recall the formulas. In the previous page, do we have any assumptions on the periodic review? Yes, it is a periodic review. So assume that L is lead time plus 1. Okay? So this is going to be a correction. Okay, so the order up to point is going to be simply the forecast of demand, okay, L, plus the estimate of the standard deviation of demand. So this is, well, this should be out of the square root. So there, I simply picked this up from the CD that, well, from the site that they give us. So there are some mistakes. So this should be square root of L times ST, standard deviation of demand, where ST and mu cap are estimates. Okay, so let me correct that. So this should be mu T cap times L plus Z times square root of L times ST. Now, let us say that the retailer is using a moving average technique. So remember what was moving average. Let's say that we are using P periods. So what's happening is that then the estimate is going to be you take the last P demands and take the average. And how do you estimate the standard deviation? Well, you simply take the expected value and then use the last P demands, okay, and estimate a standard deviation over the last P demands. Okay. So you need to correct this again, don't forget. Now, given this simple environment, in one of the papers that I was mentioning, the NRL paper, what they have done is basically they were able to quantify the bullwhip effect. The derivation is not that difficult. I prefer to work on different models rather than the forecasting effect. And so what we are after is the following. We have a certain variance of the demand, the original demand, and then we have a certain variance of the orders which are given by the retailers. So what we are going to do is variance T is the variance of the customer demand as observed by the retailer. Variance Q is the variance of orders placed by the retailer. So if you take the ratio of variance Q divided by variance T, you're gonna be able to observe the bullwhip effect. Because that is basically, it simply tells us the ratio is going to tell us the rate in which the variability increases. Variability is measured by the standard deviation or the variance. Of course, we expect this number to be larger than 1. It's always larger than 1. Moreover, but it can be equal to 1 under perfect conditions. But it turns out that in these circumstances that we were talking about, this ratio is shown in that paper to be larger than 1 plus 2L divided by P plus 2L squared divided by P squared. So this is the effect that comes from estimating the mean value, and this is the effect that comes from estimating the variance. The derivation is in that paper, and we are not going to see that. Now, but the idea is actually you can see that it's very nice. If you have a very large L, of course this is going to increase the bullwhip effect. If you have a small p, it is going to increase the bullwhip effect. What is the meaning of a small p? If you have a forecaster which operates with a very small window, then the variability that you are going to see in the demand forecast will be large. So P small means that your forecasting technique is not that good. Now you can see that if P goes to infinity, if you have a P value that goes to infinity under very standard conditions, then these numbers are going to be basically getting very close to zero if you have very large P. So you can see that, but the problem is in real life, of course, the demands are never stationary. So having P infinity doesn't mean much because you don't have stationary demand. This model assumes that you have stationary demand, but in real life, there's always a trend, an increasing part, so on and so forth. So you, on purpose, take P as a small number, so that is going to reflect the changes in the market. If you take P as 35 years, then of course new changes are not going to come into picture. So you always have this dilemma. You want to reflect the reality, you take a small p, then your variance of orders are going to increase. So this is basically what is observed in that paper. Now, let us see another example. This is again another paper by Simchi-Levy, which is not, I think, in the reading list. Well, might be. I don't remember, to tell you the truth. Okay, and so what we have is, now what happens if we centralize the demand information? You suggested that why don't we make everybody know the same demand? Now, we are going to provide the same thing. So we are going to provide each stage of supply chain with complete information on the actual customer demand, which means that you have point of sales data available at the manufacturer as well, which is becoming a reality in these days. Although you can see that if we're talking about an item which is sold in retail, in Turkey, we only have probably 20% recorded in the point of sales data, because you never have point of sales data coming from bakkals, which is still we still have, I think, if I'm not mistaken, 60% of the trade is going through the bakkals in Turkey. So you still don't have 60% of the data, even if you have all the other real data, the cashier's data and so on, available to you. So you can see that actually this is not very easy. But let's say that each stage of supply chain has the complete information. Now we can create more accurate forecasts from the previous stage. So what retailer does not make its forecast information available to the remainder of the supply chain. You see, still, the data can be available, but the retailer is going to use that data in the way that they want, and the other stages are going to use that data in the way that they want. Even in that case, we are going to see the bullwhip effect. Now, this is the case where everything is decentralized. So they found out that if you have k stages, okay, this is the kth stage, so this is going to be the variance, if it is decentralized, which means that we are not giving the information at all. So the bullwhip effect is going to be increasing in an enormous manner. It has a multiplier effect as you go away from the source of the data. Now, next slide is going to show the case. Oops, where is that? I need to have another one. Oh, I don't have that. I think I erased it in one way or another. Well, it turns out that the next one is when you share the information, you still have the bullwhip effect because of the basically you have the lead time and you have the p-value coming into picture, but this multiplication is going to be replaced by summation. So you decrease the bullwhip effect in an enormous way, but still there is a bullwhip effect which is left, because you need to do forecasting yourself. Of course, the next step is to do joint forecasting. So this is the case where we have decentralized, and there should be another picture, and I will supply you that next time. Okay, another slide, which is going to be summation. So there is a decrease, but it's not that large. Okay, so this is basically the idea. Even if you centralize demand information, you cannot eliminate it completely. The bullwhip effect is still going to be there. And what are the things that we need to coping with the bullwhip effect? Well, we can reduce the uncertainty. One is centralized information. Reducing variability. Reducing variability means that we can play with the customer demand process. That's number one. You can always do that. Or you can use some strategies which are called everyday low price. This is actually a strategy which is proposed and implemented by Walmart. What they do is even if they sell something to a discount price, they promise that they are going to have that discount throughout until eternity, throughout the year until eternity. In other words, they claim that they are going to have those discounts continuing. So you don't have the urge of buying and stocking. Your motivation of buying is only because you need them. So they make this as a strategy, and they promise this. So in order to persuade customers, actually, they did a lot of things when they were establishing it. Now, people know that whenever they go there, they are going to find certain things to very cheap prices. So you have that strategy. Rather than discounting and then increasing the price, discounting, they are setting their prices to a very low level so that they can sell continuously. So this is one of the other things. Now, we are going to continue this after the break. I have 2 or 3 more pages. But basically, we are going to see certain things in general. And of course, in some papers, we are going to see how these are implemented. Any questions? Okay, I'll see you after the break.